This is the first tutorial in the computer architecture course. Today we will talk about how to write programs using MIPS assembly. We will also take a look at the SPIM simulation environment to run programs written in MIPS assembly. For the assembly part, we'll look at the program segments of a MIPS assembly program and how these segments are laid out in the process stack, how we can access memory and extend that to larger structures in the memory such as arrays and strings. We'll take a look at constructing loops, writing subroutines or function calls, and also constructing the switch statement. We take an example MIPS program here. At the moment, we shouldn't be too concerned about what it does. It has two segments, namely the data segment, which contains the declarations and initializations of all the static data that will be used in the program. Secondly, it has the text segment, which contains all the instructions that manipulate or perform computations on the data. The operating system organizes these segments of a program into a process stack, which looks something like this. The data segment is placed after the text segment. One reason to do is because often programs increase their data space at runtime to fit more data. This method is called dynamic allocation or late binding. Besides these two segments, there is yet another structure in the process stack called the stack segment. It is used in function calls and expands and shrinks during a typical program execution. We'll go into more detail about it later. An interesting thing to note is that the stack starts at the higher address range, as it can be seen, the higher address range, and grows downwards towards the lower address range. And in contrast to that, the dynamic data segment grows upwards from the lower address range towards the higher address range. For now, just remember that and we'll come back to it later. So we look at an example called first try on this slide. As you can see that it doesn't have a data segment at all, just instructions. Now remember that starting point of every program is the instruction pointed by the label main. So in this case it's going to be this instruction, the add I. That is where your program will start executing. We have added comments at the beginning with the hash sign to explain what these instructions do. When you write your programs, you should try to do the same to remember which part of the program does what. Otherwise, it can get very confusing. You'll actually need the SPIM simulator to run this program. You can find more instructions on the course webpage as to where you can download SPIM. So SPIM has a tiny operating system in it which performs some initializations and links your program to execute it. It particularly uses the jump and link instruction to do that, which sets the RA register to point to some instruction in the operating system. So when the program finishes and executes that instruction, the jump register instruction uses the address in the RA register or the return address register to return the control back to the operating system. Now I'll demo this effect on the SPIM simulator. But before that, the question you really need to answer is, how are the jump and link and the jump registers instructions different?